We have defined a series as the sum of all the terms in a sequence. And what we've been concerned about is whether or not that sum converges to some finite number or not, right? Okay, so now what we're going to do is we're going to define a function based on a series, a collection of series. And as a function, what we want to know is what its domain is. And that's called the interval of convergence. And you can think of this radius basically as like how big is that domain. Okay, so we're going to start with a couple of warm-up questions. You know what we like to do. Which of the following converge? And if you take a look at these, each one of these things looks like a geometric series because you just have some sort of number that's raised to a power. This should be extraordinarily easy. Okay, so on this first one, here, let's color code this. Oops. Let's see, this one's red. Okay, so here your r is equal to a half, which is less than 1, so this one definitely converges. Not only does it converge, its sum is equal to, all right, what would I get if I stick in a 0 here? If I stick in a 0, 1 half to the 0 power is 1, that's our first term, over 1 minus, our common ratio is half, 1 over a half, which is equal to 2. So not only does this thing converge, it converges to 2. If you add up all the terms. Okay, let's go with orange. All right, here, obviously, our r is equal to 2, which is bigger than 1, so now this guy is going to diverge. All right, it's going to shoot off to infinity. Get a blue. All right, I'm going to say this is approximately that color blue. That's pretty good. All right, so our r here is equal to 3 halves, which also is greater than 1. Nope, that thing's going to diverge. And then we have one more. Let's go with this one. Here, our r value is equal to 2/3. 2/3 is less than 1, so yeah, check mark, and its sum we can also compute if we stick in 0 here. 2/3 to the 0 power is 1. Our first term is 1 over 1 minus the common ratio. 2/3, 1 over 1/3, which is equal to 3. So it's going to converge to 3. Okay, yeah, and so on this next slide, yeah, what we just discovered, those are the two convergent series and what they specifically converge to. Now, what if we take out the 1 half? What if we take out the 2/3 and we replace it with an x right here? Oh yeah, there you go. You replace it with an x, and we want to know, hey, what are all the values for which this new series converges? This is what's called a power series because you get a variable that's in here that can change, and whenever it changes, it creates a new series. All right, and what we want to know is, well, what are all of the values for x that make this a series that does in fact converge? Well, as if we take this thing as geometric, this thing, this x value, its absolute value has to be less than 1. So it looks like this. All right, this is a less and inequality, which means that x, the value of x, is going to be sandwiched in between a positive and a negative 1, like so. This thing is basically the domain of this. If we just define this thing as a function, that's its domain. Any number that we stick in between -1 and +1, this thing is going to make a convergent series of constant numbers, right? So for example, we could stick in a half, we could stick in -1/2, we can stick in 2/3. As a matter of fact, that's two of the ones from the first warm-up exercise here. Okay, so this number 1 right here, that's the radius of convergence. And the domain that we just figured out here, its special name is the interval of convergence. And these are the two things that we want to figure out for a given power series, and that's what our objective is. You're going to be able to find the radius and the interval of convergence of a power series. Maybe you recognize this screenshot from some sort of movie, I don't know, something about a convergence. Okay, so in the next video, we'll formally define what a power series is and then start talking about how we find its domain called the interval of convergence.